So with this lesson, we're going to talk about simple interest. We'll relate it to compound interest, which is still part of the same ALEKS assignment, but break apart simple interest in section 7.3 and compound interest in section 7.4. The important thing to know about interest in general, it's the dollar amount or a fee that we get paid for lending or borrowing money. The simple interest is when that interest is only compounded on the original amount. It's only computed on the original amount, excuse me. And then compound interest, you pay essentially interest on the original amount and interest on the interest. And so compound interest is always one of those things that we say is really good if you're the one lending the money, and it's really bad if you're the one borrowing the money. And as you do some problems, you'll see that there's quite a big difference between simple and compound interest. The principal, that's always the amount of money that we're either putting in initially or borrowing. The rate is the percent of interest that will be charged or paid. And you want to change that to a decimal before you do any calculations, and we'll talk more about that. The time, here's where a lot of mistakes are made. The time is the amount that the interest is charged, and you want to make sure that that time always matches the rate. So in other words, if the rate is given as a percent per year, then the time has to be converted into years. And so we'll talk more about that as we see some examples. So in general, first formula that you see is interest is PRT, so that's principal times rate times time. That's one you pretty much have to have memorized. You can the formula sheet that ALEKS lets you have, you'll be able to look that one up, but you'll do that often enough that you should have it memorized. I'm going to run through some quick examples. You'll notice I've already got these written out because I really want to talk more about the why than the what. This first one says, find the simple interest owed if you borrow $15,495 at 6.5% for 6 years. So that's pretty straightforward. The only important thing there is convert that percent to a decimal. So notice that's 0.0625. So then there's the principal times 0.0625, that's the rate, times the time. So that gives you an amount of interest. And so there's that first one. Second one says if you deposit $5,000 in a savings account, 4% simple yearly interest. Assume that interest is mailed to you, not deposited back in the account. So in other words, how much interest will you earn at the first year? So for 1 year, principal times rate times time. So 4% is 0.04 times 1 year. So that'd be $200. So in 5 years, that's 5,000 times 0.04 times 5. There's $1,000. So after 5 years, you'll have $1,000. If you take that interest and put it back in the account, how much will be in the account after 5 years? Well, if you had the initial 5,000 and you earned an extra 1,000 in interest, so that net you $6,000 total. Let's just move on here. Here's one that if you take out a loan, $1,200, 7.5% simple interest, and the loan is to be paid back 4 months later, then notice principal is still $1,200, rate is 0.075, but time we need to put that as 4/12. The reason it has to be 4/12 is our rate is 7.5% for the year. So time, even though it said 4 months, we have to put 4/12 of a year. So our time is actually a third of a year. So then you do that calculation, you get $30 in interest. The future value of that loan is the original $1,200 plus $30 in interest. So that future value, that amount turns out to be $1,230. And that sort of leads us to our future value formula, where if you look at this, here's the way it's given. You'll see that it's A equals P times that quantity 1 plus RT. And that's one of those things that we really want you to have memorized. but if you look at it, it actually makes sense. That's saying that the amount in the account will be original principal P plus PRT. That's the interest, P times R times T. So if you distribute this P right here, you get this formula. So here's a good way to memorize it, or at least to understand it. And either form will get you the correct answer there. So the point here is now we're not necessarily interested in the interest. We're interested in the amount in the account. So that's the future value of the loan. So here, if you take out a $3,000 loan at 6.5% simple interest, then that loan is to be paid back 125 days later. Different books, and whether it's Alex or something else, sometimes you'll be told assume there's 360 days in a year. Sometimes you'll be told assume it's 365 days in a year. You just got to assume something and make the calculation. Alex does 365 the way we write it in the book. It's 360, but as long as you follow the directions, it doesn't make any difference. The point is that the time is some fractional portion of a year. So if it's 125 days, then you put 125 over 360. Or in the case of Alex, it'd be 125 over 365. So you do that calculation, and what this tells you is the total value of the loan. So that's $3,067.71. So that's the total value that's owed 125 days later. Another problem here says, assume you borrow money from a family member, promise to pay them back with 8% annual simple interest at the end of 2 years. Pay them back full as promised. If you had to pay back $2,900, how much did you borrow? Well, so now we're asking this question a different way. So if the $2,900 is what you paid back, then that's the amount of the total. So you put that in for A, and what we're trying to find is P. So we're saying, really, how much did you borrow? That's the original principal. So we substitute that $2,900 in for A. We don't know P. 1 plus 0.08, that's the 8% interest. And 2 is 2 years. So we just put 2 because it was yearly interest. And so doing a little calculation here, that's 1.16. One of the things you'll see a lot of is don't do any extra rounding. Don't do any intermediate rounding. So that turned out to be exactly 1.16, so I can write that. Doing a little algebra, we divide both sides by 1.16, and so that's why you get P is 2,900 divided by 0.16, or 1.16, and so P turns out to be exactly 2,500. So what that means is you borrowed initially $2,500, but you had to pay back $2,900 because of the interest that was due. So moving on to another one here. So same idea. You plan to save $4,000 for a down payment for a new car in 18 months. You decide to put money in a certificate of deposit, so that's a CD. You hear people talking about a CD from a bank that pays 3.25% simple interest. So how much do you have to put in now to have $4,000 in 18 months? So again, that's you're trying to find P. So P, you look at this formula, A equals P times that 1 plus RT. So we don't know P, so we put everything else in here. So we put the 4,000 in, that's what we want to end up with. 1 plus 0.0325, so that's 3.25% written as a decimal. And then 18/12, because 18 months, there are 12 months in a year, so 18/12 is our fractional portion of a year. Do a little bit of a calculation here. 1.04875, that is not rounded, that's an exact number. And then go ahead and divide both sides by that to get P, and I'm going to show you something here. That's actually cool too. I'll show you that in a minute. So on the calculator, and if you do not yet have a TI-83 or 84, you definitely want to get one soon. I'm going to show you in a nutshell. Actually, I'll back up and write this way. That P was 4,000 divided by this whole thing. 1 plus 0.0325 times 18 over 12. So I'm just going to divide that. Pretend that I didn't even know that other number existed. And so that means we're going to type, all I'm doing here is showing you how to type that on a calculator. 4,000 divided by parentheses 1 plus 0.0325 times 18 twelfths, and then close. So double check that, make sure I didn't miss copy 0.0325. Yep, times 18 twelfths. And so notice that parenthesis there and there is my entire denominator. The 1 plus whatever, that was just the inside. And now when I press enter, I get that same value, 381406. There's my 381406. So sometimes I encourage students, don't over worry about trying to simplify and get some long nasty decimal. Just leave the whole expression, divide it to the other side, and get this, and you'll get a final answer here. So that is something that is worth practicing carefully. A little bit on discounted loans, and that's the last problem for this video. So if you have a discounted loan, what that means is you actually get the interest taken out before you get your money. So if it says $1,200 on a 5% simple interest rate discounted loan for a period of 14 months, well, what's the discount? Well, there's the interest. That's the amount of interest. So interest is principal times rate times time. So that's 1,200 times 0.05 times 14 twelfths. And again, that's 14 months out of 12, so 14 twelfths of a year. Do that calculation, you get $70. And so you get the loan interest taken away before they give you the rest of the money. So the amount you actually get is the principal minus the interest. So you actually get $1,130. But then you have to pay back that full $1,200. So what does that mean? That means you put that $1,130 in the principal, because that's all you actually borrowed, and you had to pay back $70. So if you, that's a little muddled up because I've already got the work shown. I'm going to write one step here to show you what this looked like initially. If you write I equals P times R times T, the point is you're trying to find R, the actual interest rate. So I know I was $70. The P was that $1,130. The R is what I don't know, and the T is that 14 twelfths still. And so all we did just to solve this, what's written in black, is multiply both sides by 12/14. That's the little fraction work that gets rid of this. And so that's for the algebra fans here. We multiply both sides by 12/14, and then all you have left is that 1130. So if you divide both sides by 1130, that leaves R by itself. And so there's the kind of the fractional form of R. And if you do all that in a calculator, you'll get that R is 0.053, which we call 5.3%. So the actual interest rate, even though it said 5, you actually end up paying 5.3%. And the reason that is, it goes back to the fact that you had to pay your interest up front before you actually got your money. So discount loans are a ripoff is the short version of saying that. So that's all for this video. The next one is a little bit more complicated, and I'm going to show you a lot of stuff on the calculator, so you want to tune in for that one.